All right, so how's everyone doing today? You guys glad it's Friday? It's always good to be a Friday, isn't it? So just want to kind of go over the packet tracer very briefly. So I sent out an email. Most of you should have gotten it. Actually, all of you should have gotten it. Most of you should have read it. Just basically what that is, that's going to be how we're going to be handling the labs on the days when we're not in the lab. So you can do that at your own pace. I'm not going to take a look at it until the end of the semester. So just make sure you go through the course. Still waiting on getting routers and switches from networking. So hopefully we're able to do that. If not, we'll just switch up how we do the labs a little bit. But like I say, we'll cross that bridge if we get there. Hopefully we won't. But of course, some things are outside of my control by just a little bit. So like I say, I definitely encourage you to play around with the packet tracer application. Once you get to like chapter 3, starts going into some really interesting stuff in there. First 2 chapters are basically like the interface, how to use it. Like I say, once you're able to start emulating some of the routers and switches, I think it'll be pretty cool. And you know, certainly you don't just have to do what the training tells you to. I mean, you can go off-road, do a lot of fun stuff, really sort of see how enterprise networking is used. One thing I would like to kind of say regarding that, while it is, of course, a Cisco training module, it's a Cisco application, the commands are going to be pretty much the same, you know, across different enterprise equipment. There will be some minor differences, but I think it's probably like 95% similar. So while I like to use tools from a variety of vendors, unfortunately, it's not really going to be feasible in every case. So, you know, if HP put out a free version of something similar, you know, I'd encourage you to use them both, but they don't. So it's really a way for Cisco to kind of make sure that professionals, people in training, are well-versed in Cisco products so that, you know, if they become in a position, make hiring, or not hiring decisions, but purchasing decisions, that would certainly be beneficial for Cisco now, wouldn't it? So again, that's just kind of where it's at. But like I say, it's going to be very, very similar no matter which platform you're on. You know, Cisco, iOS, HP's, Arubas, they're all going to be very similar in the commands and what you can do with them. So today we're talking about networking devices. I'm going to talk a little bit about some common networking devices, get into some specialized stuff, and then wrap up the unit with talking about planning networks. So just kind of go through these very briefly. These should be stuff you're pretty familiar with. Of course, a network interface card could be wired or wireless. And what it's going to do is allow you to communicate with a network of some sort. Of course, we know that a network interface card has a unique MAC address. That's how routers and switches are going to send it the correct packets. Make sure that it's not sending it to everywhere, as we would with a hub, that sort of stuff. So of course, a hub, it's going to be a device that allows us to have multiple ports. The problem with a hub, of course, is that it's not going to recognize a MAC address, and basically anything on the hub will receive all the packets, and that puts a lot of strain on a network interface card to have to go through every single packet coming in and out of the network. So, you know, back in the day, that would lead to premature network interface card failure. It probably would be less likely to do so today, just given, you know, what a network interface card is capable of today versus back then. But you're not going to run into a hub, at least not a physical hub, very likely, simply because a switch basically the same cost, and it's going to have a lot more features, a lot more flexibility, and especially when we get into stuff like managed switches, you know, being able to assign a port to a certain device, tons of different things we can do with that. Of course, a switch, it's going to be a device that allows us to have multiple wired ports, and the whole advantage of that is that we can, in most cases, manage it. But even if we can't, it's still going to be smart enough to recognize a MAC address and only send a packet to the MAC address the destination is going to. So it's going to be what you're going to run into almost all the time. Talk about a router a little bit. Of course, a router is what allows us to do sort of the routing of the individual packets. You know, not to be confused with a switch. It's going to be able to do a lot more in terms of setting up things like a VLAN. You can't do that on a switch. So you have to have a router on the network. Well, let me rephrase that. There are a few cases where you wouldn't, but it's still going to be best practice to have at least one router somewhere on the network so you can really sort of segment the network using stuff like VLANs, all that sort of stuff, and really just set all the rules. Okay, of course, an access point is going to be a device that broadcasts a wireless signal. Typically, we're thinking like 802.11 for that. Although there's, of course, many types of access points beyond that. But just for this class, think 802.11. And, we think about a commercial standpoint, we have access points. They're not to be confused with a wireless router. So the book actually does confuse them. If you look at the book's picture, they're talking about a wireless router in the image. They're talking about an access point in the text. So a little bit funny. I like to make fun of the book. So, basically what we're doing, though, is we're not having any routing happen on it. An access point is, in a way, pretty similar to a hub because, if you're sending out the information, it goes out to every device. Okay, every device could theoretically listen in on it. And that's something I'd encourage you to do on your home network. Just go through something like Wireshark, some sort of tool where you can capture the packets. Can't do it with Packet Tracer, but Wireshark is a good one. Several others as well. And just look at the individual things that are being passed to and from the access point. There's going to be a lot of send and acknowledge, synchronize and acknowledge and all that sort of stuff. Of course, a wireless range extender. Not going to see these too much in a commercial environment because you just plug in another access point, extend the network that way. That makes a lot more sense. But for a home use, you may have a case where there's some sort of range extender that's operating on the same frequency, and as opposed to having a physical cable running into it, what it does is it listens in and it just rebroadcasts the signal pretty much verbatim. Reason you wouldn't see that in a commercial environment, it's going to have lots of issues with potential interference. You're taking a signal and rebroadcasting it. If you were doing that on a large scale, you would certainly run into just a multitude of issues. So access points are quite simple. All you have to do is just run PoE into them, make sure they're adopted by whatever wireless controller, be it hardware or software you're using, and push a configuration to it, you're good. Very straightforward. A lot of places will have access points in it. I don't see any in this room, but there could be one in the ceiling. I don't really know how they laid out the network, but just know that's the difference between that and a wireless router. Wireless router has additional functions, which you definitely do not want for a commercial application because, they're not going to be very well suited for that. Any questions about the basic networking devices? Like I said, this should be stuff that you hopefully already have a pretty good understanding of. So now we're going to talk a little bit about bridges. And the book doesn't really say this, but bridges can be hardware or software. I would say more common, you're going to have a software bridge. And basically what these are going to do, it's going to have different segments of the network, and it's going to allow you to pass packets between them. But more importantly, it's going to segregate the different collision domains. So if you had one big collision domain, you could break it into multiple collision domains using a bridge. And of course, the way that it does this, everything about it, it's all about the MAC address. It's the individual device, because that's going to be the thing that's not going to change from, say, reboot to reboot. We're going to talk about DHCP here in a little bit, but an IP address, even a local address, can certainly change from whenever you reboot, because as you reconnect, you're going to contact DHCP server, hopefully get an address, and that address could be random. We're also going to talk about static IP, but for the most part, to understand that we're talking about a network. Most of the time, we're talking about how the switch and router recognizes which device to send it to. Almost always the MAC address. So firewall. Firewall, as the name would imply, is going to prevent unauthorized access. Now, how does it do that? Well, it's simple. It's going to have mechanisms in place to be able to control where traffic comes in from, where you allow the traffic to reach, all that sort of stuff. So you have different ports, of course. I'm not talking about like a physical port. I'm talking about like port 8080. Maybe you want to block it. Maybe you don't. You have the option with the firewall to determine that. And beyond that, though, you can use a port and use a different protocol. So just because the port 443 thing is HTTP doesn't mean you have to use it for that. So that's where something like deep packet inspection comes in. The gist of deep packet inspection is it inspects each individual packet to make sure that what it's saying it's going to do is actually what it's doing. So we'll cover that in a little bit more detail. Probably also covered a lot more detail in next class, which of course is security. So hopefully most of you guys will be in security class. We'll probably do a lab with a firewall in there, just kind of see how it works. But don't think of this as being some physical hardware device. There are certainly many physical hardware firewalls, but they don't have to be. For example, open source application, or I guess technically open source operating system, pfSense. Anyone ever used pfSense before? Check it out sometime if you want to. It's basically a firewall with some routing capabilities as well. And you can configure it however you want. Stick it in a VM, you're good to go. So that's kind of what we're doing. And whenever we're setting up a firewall, it's important to use the implicit deny. So what we do is, the very last rule is deny. Okay, it's implicit deny, because what we're saying is, if it didn't basically pass one of these rules where we allow it in, we're going to reject it from being onto our network. Does that make sense? So like I say, we don't have a ton of time to cover that right now, but definitely in the security chapter, or the security class, we'll definitely be covering that in a lot more detail. Then, of course, we also have the demilitarized zone. So basically, what the demilitarized zone is it is a space where the public can access it. So we see internet, that's basically the general public. We're going to allow some stuff in, but then we have possibly a second firewall. That's one way to do it. It's not the only way to do it. You could certainly get away with doing one firewall. You don't have to have two different devices. You certainly can, and there are cases where you'd want to, but there's also cases where you wouldn't want to. So firewalls are going to be able to support a DMZ with one in most cases. But basically, like I say, public can get in to part of it. Maybe you have like a public-facing website, and maybe you have private resources. So your internal network is going to be protected by a different set of rules, or possibly a different firewall. Does that make sense? Any questions? All right. So another sort of thing we'll probably cover in a little bit more detail in security class is the intrusion detection system and intrusion prevention system. So, one way of thinking of this is, if you want to prevent something from happening, how do you do it? You do it proactively. You have proactive rules. You have proactive policies in place to prevent some action from transpiring. So what that's going to do is that's going to stop something from happening. So let's say that you had a malware system that was an enterprise piece of software. And what it would do, of course, we know with enterprise malware applications, or anti-malware, I should say, it's going to basically report back to some central device or server, or maybe some central cloud, some central reporting, such that if a PC is infected, the IT department can respond to it. They can see what was accessed, and that's going to be more in line with preventing threats. Of course, detecting them is also important. So we have intrusion detection systems, and this is going to be a lot more common on like a server, to where you can see, was a server accessed without authorization, and if it already happened, you still want to know about it. You want to know what specifically was changed on that server. So let's say you had a customer database, and you want to have not only an intrusion prevention system. You definitely want to keep people from accessing it in the first place, but maybe some people are smart enough to get through. So that's where the intrusion detection system would come in. It's going to basically just provide an alert in whichever fashion you select to sort of let people know, or let the IT department or IS department, whatever you have, know that some access took place. Here's what was changed. And that's very beneficial, because if you are suffer some sort of data breach, you have to know what information was accessed, how it was accessed, all that sort of stuff. That's where the IDS comes in. Of course, kind of talking about that, like I said, most of the time that is going to be running on some device. Most of the time that is going to be a server. Why would you not want to run it on an individual computer? Well, there's a lot of reasons. So number one, how do you manage that? Number two, imagine the false identifications. Number three, you're a lot better off with an individual computer in most cases to just use an IPS and do all that sort of stuff. So that's basically what we're going to be going into with these for now. Talk about contention methods a little bit. So last class we talked about collision detection, and this class we're going to add in collision avoidance. So this is just where we're talking about carrier sense multiple access with collision avoidance. And this is specific to wireless devices. Of course, the reason for that is, how does a wireless device know that a collision occurred? Well, it can't. Therefore, it can only use collision avoidance. So the whole process behind this, what you're going to do is, whenever you're sending anything out wirelessly, you're going to check for traffic. If it's not clear, what it's going to do is it's going to make a timer. And this timer is going to be a random sort of amount of time, and it's called the random backoff algorithm. And once that timer is done, then it'll repeat the process, basically. So if it's clear, it's going to go ahead and send that frame. And the frame, of course, goes to the AP. AP sends back an acknowledge signal. And like I say, this is where I recommend on your home network, not on the campus network, of course. I don't want to get in too much trouble with the IT department around here. Just run Wireshark. Look at what's happening with all your different devices on your personal wireless network. So for example, who has a smart TV in here? You think that's submitting a lot of data, even when you're not using it actively? It probably is. You can check it out. You guys probably have a laptop, most of you. I'm assuming you guys have a smartphone. What other types of devices do you have that might be on your wireless network? Okay, so some sort of like smart speaker, personal assistant, that sort of stuff. It'd be kind of interesting to see what that's sending out, wouldn't it? So check it out, It's not a homework assignment or anything, just probably something that might be fun to do if you have a couple minutes downtime. And you'll see there'll be a lot of traffic going across it. So, when you're waiting, you don't notice the wait. You might notice the wait if it's, a substantial wait. But this is happening. I mean, we're talking, milliseconds. A lot of times less than that. So that's why having, appropriately scaled network is very important. Because let's say you have 100 devices that are streaming video on a single access point. Is that theoretically possible? It's theoretically possible, especially, there are commercial access points that support upwards of 1,000 devices for high density areas. Is that going to be a good experience? Most likely. Probably not the best. It's like I say, one device at a time, basically. So, wireless is good, but, even the book talks about you're probably only going to reach half of your theoretical speed. Now, I would say that in 2021, you can probably get a little bit more than half of your theoretical speed from your access point, but you're probably definitely not going to get 100%. Just a lot of overhead that happens, and it has to happen, It's not like we can not do this, because what happens if we don't have collision avoidance for a wireless network? Would it work? Maybe with one or two devices, but certainly not with the multitude of devices and chatty things like TVs and all of that other sort of stuff that just didn't have, 20 years ago. You guys remember CRTs? Did anyone own a smart CRT? Probably not. Did they exist? Not to my knowledge, but it's very possible that some Japanese company somewhere made one at some point. But for the most part, this is what we're talking about. Okay, so we went through collision detection last class. I'll just kind of briefly go through it. It's for wired connections, because with wired you can actually detect collision. And basically what it's going to do is it's going to check for existing transmission. Process known as carrier sense. If it's clear, it transmits. If there's another host that was transmitting, you didn't detect it, of course, then there's a collision. Now, in modern networks, this is rare, but it can occur. And basically, if it's not clear, it just uses a random backoff algorithm and just repeats the process. So that's what we're talking about with wired networks. I've got a quick little video. I got to change the audio and also change the video, so just give me 1 second over here, guys. Any space balls? That is one of the downsides of having to record all the lectures is, well, you gotta really do some work if you want to play a video, otherwise you get a copyright strike. And we want to avoid that. What's that talking about, though? So jamming the signal. So basically what you're doing, if you're saying to all the other devices, you cannot transmit because I'm transmitting. Now, do you use it with physical Raspberry jam? Obviously you don't. But I think that's kind of a humorous little way to kind of introduce the topic of jamming. Let's talk about DHCP. So DHCP is basically dynamic IP addressing. So the actual name of it is Dynamic Host Configuration Protocol. And all we're really doing with DHCP, we're just taking an IP address pool. It could be Class A, Class B, or Class C. We'll talk about that in a couple chapters. But basically, we're just assigning it to individual hosts. So, of course, who remembers what a host is? What is a host? It's a device on a network with an IP address. So it could be any device at all. And what we're doing is dynamically. So let's say hypothetically you have a bad DHCP address. Maybe the DHCP server, for whatever reason, let's say it gave you a duplicate. What's the best way to resolve that? Just reboot your computer. You'll get a new address. Now you could also renew the lease on the IP address, do all that sort of stuff. Of course, speaking of leases with an IP, with DHCP, of course, you can set that to whatever you want. Maybe you're a restaurant, you want to have a 2-hour lease because you figure a patron should be able to come in, maybe do whatever they do in a restaurant, I'm assuming eat, maybe drink, and then, of course, by 2 hours, they probably have left. So you set a 2-hour lease. Let's say you're a hotel. What do you do in a hotel? So you're sleeping. So probably you want to set a 24-hour lease. Let's say you are a school. What do you do in a school? Come learn. So maybe an 8-hour lease. I mean, you can set whatever lease time you want. It's really up to you. You can set multiple weeks. There's no limitation. Or maybe there is some limitation, but there's very little limitation with the amount of lease you can set. Why would you not want to set a longer lease than you think you may need? So even with like a Class A, there's still a limited number of IP addresses, and it's best practice to make sure that people aren't having them for weeks on end because that could be a problem. Now, static IP, of course, is going to be a little bit different. And what happens with the DHCP on that is it just recognizes the MAC address of the NIC. It's the main way to do it. There are other ways to do it as well. You could do it based on the port something is connected to. Anyone in here set up like a Pi hole? Few people. You got to use a static IP for that, don't you? You don't technically have to. You can get around it doing some sort of dynamic thing with like duck DNS or something. But it's a lot easier to just set a static IP. So you used the MAC address for that, didn't you? Exactly. So of course you guys know what Pi hole is, right? So Pi hole is a piece of software, and what it basically does is you have some sort of DNS server. You could use like Cloudflare's 1.1.1.1. You could use Google's 8.8.8.8. Several others as well. I'm not endorsing any particular product or service, obviously. But what it does is you download some hosts that have maybe block lists. So like there'll be a lot of different block lists. You go on the subreddit, you'll see them all. And just download them, and it'll block those DNS requests from having any resolution. So, of course, talk about DNS requests a little bit. I think that's the next slide. What it does, of course, is you have some domain name, like let's say google.com, and then you resolve that by getting the IP address of that sort of domain. Does that make sense? So again, what you can do with DHCP is you can also set certain addresses aside to not give out. So you have your range. Let's say it's a 10 dot whatever, Class A. You can determine, we don't want to give out 10.100.1.50. Maybe that's a server, maybe that's reserved. So you just reserve that, and that's all you have to do. So DHCP is really straightforward, not a whole lot to talk about with it. So, of course, one other thing though, a DHCP can only go across its collision domain. So if you want to get that across multiple broadcast domains, just use a DHCP relay. And almost every time this is going to be a software, most of the time it's going to be on the router. And what the router is going to do is it's going to recognize a DHCP request, and it's going to forward it to wherever your DHCP server is, wherever you configured it to be. So that's all we're really doing there, really straightforward. IP address management, another straightforward thing. As the name would imply, what we're doing is we're having software, or it could be technically hardware, but I haven't really seen many hardware appliances that do this, because basically it's just software that tells you this is the IP addresses that are in use, these are the devices using them, and it really allows you to plan. So let's say you're planning out an enterprise network. Someone throw me a number of enterprise devices that may be on the network at any given time. Any number. How about 25,000? Does that sound cool? So you plan that out. You see how many devices need to be on it. Obviously, you want to have more than you'd expect to need. And then basically you just plan. You could see what's using an IP address at a given time. Maybe see some information about it, see what traffic they're passing, see where they're going. Of course, manage the IP addresses. Maybe you want to revoke a lease. So you can certainly do that. Now, the good news is you don't have to evict anyone. This is not like that type of lease, but it's certainly a lot easier to manage using IP address management platforms. And this will be built into whatever DHCP server you're using most of the time. Be built into the router. You'll have lots of tools at your disposal. And of course, to do this, obviously it has to integrate into the DNS and DHCP servers. Multilayer switch. So basically, think of this as just a switch with some additional features. It's not really to be confused with a managed switch, but it's a lot like a managed switch, where you can go in, assign certain things to the switch. But this allows for some limited routing capabilities. So it's not going to be a full router. Don't think of this as being a full router. What this allows you to do is to put each of the ports on the switch on a separate collision domain. So there could be some situations where you want to have a very small collision domain. Obviously, you don't want to go out and buy 20 routers. That'd be a big expense. So you could buy something like this and allow you to sort of mitigate some of the problems that you may face with a crowded collision domain. The main difference is how this actually takes place. So of course, we're using ASIC hardware, and that's going to be very specific to one particular purpose. So think about a Bitcoin ASIC miner. Okay, what else can you do with one of those? Not really much at all, because the chip is designed for like one or two, just a handful of tasks. It's not going to be very versatile. For a multi-layer switch, that's perfect. It only needs to do a couple extra things from a switch. But a router, obviously, is going to be doing a lot more tasks. It's going to be able to need to have a lot more flexibility associated with it. So that's why it's going to use a microprocessor of some sort. There's just a ton of different ones, a lot of proprietary ones as well in this space. So kind of keep that in mind. All right, then we have the load balancer. So load balancer has one main purpose. It's basically take incoming packets and just send them across to different machines. So let's say we have 4 web servers that can each handle web requests. So just go ahead and, draw this out on the board here. So load balancer. Okay, so this is coming in. We have a little cloud of the internet here. And it's going to be able to send it off to whatever servers we want. So we're just going to call this guy S1, S2, S3, and S4. Okay, so all it's doing is just, and it kind of does that by whatever you tell it to. So one thing is least load. Look on these different servers, see which one is the least utilized at a given time, send it there. You could do fault tolerance. So let's say server 2 is down. Would the load balancer send anything to server 2? No, it wouldn't. Fastest response time, see which one. So basically, that's going to actually add a lot of traffic, add some overhead. But you'd basically send out a ping to all the different servers, and whichever one responds the quickest, that's who gets the load. You could also do division. This is where we get into talking about security a little bit. So you can send it to all of the servers. So you have an incoming request, send part of it to all of them. You're going to mitigate some risk that way. There's some attacks that will only work if it goes to a single server. Like I said, we'll cover a lot more of that in the security class. But for now, just know that a load balancer can potentially mitigate some very limited threats, although mostly it's in place to provide a better end experience. So DNS, basically what you're doing with DNS is you are taking a domain and you're converting it to an IP address. So that's pretty straightforward there. We see an example here, have a device on the internet, and it's going to come in. Obviously, it has some sort of DNS address to be able to connect to our external server. And then, of course, you have internal stuff. It's going to do the same thing to reach the internet. Does that make sense? So, with this, you're almost always going to have to use some third party because, can you download a list of every domain? It's theoretically possible. Is it practical, though? Is it really practical to keep an updated list, even if you're a pretty large company? It's probably not going to be practical to keep that list updated. So that's why you would use that. And then, of course, you have dynamic DNS. It's going to be more for an internal network, where basically it's going to provide host name resolution. So basically self-register the address, and it's going to allow you to communicate across the internal network that way. So now we have proxy servers. Proxy servers are going to basically provide a proxy to just route requests, almost like a load balancer, only it's going to provide us several advantages. The main one is going to be traffic control, which load balancer also provides. But what this does is this allows you to send a request for anything to one place, and it will determine where it goes. So it's almost like a router and load balancer in one, where it kind of is able to send packets to where they need to go, and it's also going to allow you to send different protocols. So a load balancer, for example, it's going to be more geared toward one specific task. So you have a web address for your load balancer in a lot of cases, where you would have different servers that you'd be able to send the request to. Proxy server is going to be basically the server for everything, or a lot of things. I wouldn't say everything. So web proxy is one example, where basically it's going to be caching web content, and this happens on a local device. This can happen across a network. So for example, it is theoretically possible, and some firms do it. Say you have an iOS update coming down the pipe. Okay, you could have a web proxy that would cache that iOS update such that someone downloads, they don't have to go all the way out to the internet, go off to Apple servers. They can instead go to your local servers. That is possible. Of course, caching proxy servers, not limited to web content. Still caching though. So that's what we're doing there. Does that kind of make sense? All right, encryption devices. So encryption devices, they can be dedicated hardware, but they don't have to be. So pretty much every processor from Intel or AMD, I want to say Intel added RSA in their second gen I-series. Definitely don't quote me on that, but it was a long time ago, definitely around 10 years ago. So you don't really need to have dedicated hardware to do things like file encryption on a network because the device is capable of doing it. And why would you centralize something that's done better on the local device? That way there's no transmission that happens unencrypted. Does that make sense? So this is kind of obsolete, but it's not necessarily obsolete because you could also do this with web content filtering. So there's a lot of regulations around this. For example, CIPA, Child Internet Protection Act. It's not going to be relevant to anything but a institution that serves people under the age of 18, providing them with a network. So for example, public libraries, public schools, they're going to have some sort of filter in place to prevent them from viewing adult content. I think we all know what that is. So basically how these work in modern day is they have the SSL, and they actually break that SSL, and then they see where they're actually accessing. And then, of course, they have different ways they can block it. They can block it via DNS. They can block it via website as a whole, use some sort of a blacklist. I mean, a multitude of different ways, but just kind of understand they're breaking the SSL because, 10, 20 years ago, were most sites using SSL? HTTPS. Were they using that? No. In modern day, though, almost every website is using it. In fact, it's somewhat difficult to find sites that aren't using it. So when we're talking about that, that's what we're doing. And obviously, this has to happen with some sort of consent. Basically, that consent is, if you're on the network, you agree to the terms. It can be implied, it can be not implied. Of course, the device also has to agree to have that happen, and you do that, of course, with a certificate authority. So load on a CA to access the network, and you'll be able to sort of agree to using the CA that is on the filtering system. So there's going to be some inherent speed loss with this, just given the nature of what's happening. You're taking every packet, and you're basically breaking SSL through its SSL, and you're just examining every single request. Looking at a huge database, you're going to have billions of sites in this database. So comparing it to that, I mean, it's going to be a little bit slower. A good one, you're not going to notice the speed loss, but it will still be present just because you're doing stuff you wouldn't otherwise do. Does that make sense? All right. So a packet shaper is going to be some device that is going to allow us to sort of examine each packet going across the network and basically take the packet and reformat it a little bit to match whatever our internal company policy is. So this is going to be used heavily in corporate environments. Not going to see it outside of a corporate environment. But basically, it's going to help us sort of maximize our network performance by doing things to make sure that however we expect to handle a packet will be how we ultimately handle that packet. So it's going to basically allow us to reduce latency, have better performance, that sort of stuff. A VOIP, go over this briefly. Of course, it's voice over internet protocol. It's for submitting audio transmissions via a network connection. One part of this is going to be the VoIP private branch exchange. So if you think back to analog phone systems, these are private branch exchange. And what that basically allowed us to do was to have phone calls come in and route them to internal lines where they need to go. So for example, let's say I'm in my office, I have my office phone, I call up Paul, okay? So the private branch exchange is going to send my call to Paul. Does that make sense? So pretty straightforward. And of course, I have VoIP endpoint. So what is an endpoint? What is an endpoint? Who can tell me what an endpoint is? Well, an endpoint is just going to be a device on a network. It's almost like a host, but it doesn't have to be a host. It does not have to have an IP address. But in the context of VoIP endpoint, it does, because two major types, software IP. So maybe I have an application, Skype could be an example of this. You can call people with it technically. You're not having a physical Skype phone, but having that software IP, that's one example. The other example is going to be a physical VoIP phone. So like I was talking about the example in my office. If I call up Paul on my office phone, that's an example of a VoIP endpoint. Then a VoIP gateway is going to be what's going to allow us to take those calls and route them to the public switch telephone network to actually reach outside addresses. So private branch exchange, name private implies private to an enterprise. Does that make sense? Gateway, of course, is going outside. It's a gate. So any questions about VoIP? All right. Now, here's a funny topic right here. Next generation firewall. So think back to what a firewall was. Who can tell me what a firewall was? Anyone at all? Ben, what's a firewall? Exactly. So all we're doing with a next generation firewall, it's all a marketing term, The distinction between it on paper is that it's application aware. So maybe we allow certain applications to use a certain port, but not other applications. I'm going to be honest, pretty much any modern firewall allows you to do that. I'm not going to say everyone, but for the most part, like, this term is so funny because it's just, trying to make it sound like it's, future age and all this other stuff. It's just looking at the application, making sure that it complies with one additional layer. Deep packet inspection is more likely to be found on these, but like I say, anything from the past 10 years should support deep packet inspection. You can go back 15 years and find stuff that does, although then you're getting into the more higher end stuff that would. Like I say, just understand that this is layer 7, which what is layer 7? exactly. It's the application, but it doesn't lay in layer 7. Don't be confused with that. It can see which application is using stuff. So, like I say, not a huge difference. Last thing we're going to cover today is just network planning and sort of seeing what requirements to do. So I'm just going to kind of go through. The book goes into some more things, but these are the things I think are most important. So certainly read the book, but also just kind of understand. Biggest thing that determines how a network is going to function is going to be the budget. If I give you $100,000 and I say make me a network, and it needs to support 100 users, are you going to have any trouble at all with that? Supporting 100 simultaneous connections with $100,000. If you are, well, hopefully you won't by the end of the semester, because that's a pretty beefy budget for that amount of users. Of course, budget's going to be the most important. Let's say I give you $2,000 to support 100 simultaneous users. Then you're going to have some trouble. Then you're going to be looking at brands like Ubiquity, getting into the Unify ecosystem. It'd be technically possible. Would it be a perfect experience, especially to manage? Do you guys ever manage a Unify network before? It's not as feature-rich, but I mean, for the money, it's pretty good stuff. And like I said, I'm not endorsing anything or criticizing either, but just being real. Like, you're not going to be able to go to Cisco and say, I need to support 100 users. Here's $2,000 to do it. Obviously, they're going to say, it's not enough money. But it is theoretically possible. It's just not going to be necessarily as robust a network and all that sort of stuff. So number of hosts, obviously. Why is that important? Why does it matter how many hosts we have on a network? Yeah. So collisions, yes, certainly. You want to think about how do we have equipment that can support, having 100 different users on at a time. Types of hosts. So if you have a firm that uses, let's say, hot desking, where each day you come in, just grab whatever desk is available, okay? And you're using a laptop to connect, so you just basically have a wireless network. Do you need to have a lot of wired access ports? Probably not. Let's contrast that. Let's say you're a firm that uses individual offices for every employee, and each employee gets a desktop. Then you'd probably want to consider. So just consider the type of host. Also think about where the hosts are going to be. Are you going to have digital signage? If you do, probably want to run some sort of a cable to it. Probably going to be like Cat6 or something, but kind of make that decision. Physical space. Why is physical space important? So this is physical space of a lot of things. Think about physical space of a network closet. You guys went to several, I believe. Think about what you have in the physical space. How much space is there to work? In other words, let's say you want to stick, I don't know, think about the lab we have. Could I stick 20 racks in that lab? It's just not enough physical space. So, you'd want to make sure you get equipment that can support a lot of stuff with just a tiny little footprint, if that were an issue. Also think about the physical space of ceilings. Think about materials. Let's say we have a building from 1870. Who could tell me something about 1870 buildings? Anything at all? Are we going to have asbestos? Okay, we probably will. Are we going to have lead paint, lead materials? Probably will. So having said that, who wants to volunteer to go in a building from the 1870s and run some fiber? Any volunteers? Oh, we got one. I'm surprised. Yeah, so I mean, with proper PPE, it's certainly doable, but you don't want to do it a lot because what do we know about asbestos? What does it cause? It causes difficulty breathing, especially if you're a smoker. Mesothelioma have a synergistic effect, 50 times more likely to develop it with asbestos exposure. Okay, that's not good. So consider the physical space, and like I say, you can certainly get respirators, wear proper equipment. But having said that, I personally wouldn't be volunteering to do it even then. Let's think about some other problems with physical spaces. Give you an example. One time I was going up into an attic, and this wasn't my personal attic by any stretch, it was a commercial environment, going up doing a little bit of consulting work, and I opened up the attic access and shined my flashlight in, and 2 dots that reflected back at me. You know what that was? That was a rat. Okay? You think I was happy to go up in that attic? Not very happy. Okay? So consider the physical space. Now, still ultimately had to go up in the attic, but I went up with a little bit more protection that sort of didn't get bitten or anything. Rats obviously can carry a lot of nasty things. You got rabies, you got impetigo, the plague. What are some other diseases rats carry? Can they carry West Nile? They're filthy creatures. They can probably carry pretty much anything. So consider your physical space. Wear proper protection. I'm not saying don't do your job. I'm just saying get proper protection. It's not very expensive. Tyvek suits run about $10, maybe a little bit more modern day, but not that expensive. Certainly is worth it. Uptime expectations. Why is that an important thing to consider? So let's say that I have a network that needs to be up 99.9% of the time. That's not an uncommon figure at all. Basically 3 or 4 hours of downtime a year. So to do that, what are we going to know we're going to need to have? Lots of redundancy, because equipment fails. Okay, and honestly, like if you're looking even at the Cisco equipment, the individual pieces of hardware are not that expensive. What gets expensive is the support contract associated with them. Obviously, they're going to be somewhat expensive, but having a spare on hand is not at all an uncommon thing. You'll see lots of server racks, and half the equipment will be powered off. You're like, what's going on? Well, it's in use in case it's ever needed, but it's not being actively used to service requests. So certainly think about uptime expectations. Security, obviously use common sense when establishing a network. Make sure that you're having reasonable security measures on it. You'll be good. Consider what redundancy needs. And lastly, environment. Why is environment an important thing? Anyone in here like to go running when it's 100 degrees outside? Why not? It's too hot, okay? So what happens when it's too hot? Can you have a heat stroke? It's possible. Hopefully it won't happen to any of you, but it could happen. It's a possibility. Okay? Heat damages humans. Okay? What about humidity? I lived in Georgia. Lived in Mississippi for 4 years. I know a thing or two about humidity. Okay? Humidity is not fun. I'm sure you guys have had some humidity days where you walk outside, you get sticky. Get a lot of sweat build up. Humidity. Now imagine you have condensing humidity in a server room. You're going to be having condensation form inside your equipment. Do you think that's going to be good or bad for the equipment? It's going to be very bad for the equipment. Most things are rated between 5% and 95%, but not everything is rated for 95%. And beyond that, let's say it's condensing humidity, you could certainly avoid a warranty that way, be out thousands of dollars. Beyond that, think about your electricity. Let's say you have humidity inside of a system that's condensing, okay, and it causes a short. Okay, what's a short going to do? Could it cause an electrical fire? It's possible. And what happens if you have an electrical fire in a data center? Well, that's not a good thing at all, is it? So another thing that's not on this list is, stuff like physical access to the data center. Stuff like make sure you have fire suppression that's not liquid-based. I think halon is the gas that's most commonly used. And let me go ahead and tell you, if you're in a data center and you hear an alarm, get out. You got 10, 15 seconds. Halon gas is likely going to come down. And is that stuff safe to breathe? Not at all. It can kill you very quickly. I'm not trying to scare anyone, but certainly, like I said, if you ever hear an alarm going off in a data center and you don't know what it is, just get out and figure it out later, Does that make sense? So, any questions about network requirements? Like I say, Monday, we'll pick up talking about IP addressing. It gets a lot more exciting. So far it's been kind of basic, It gets a lot more exciting as we go, though. So, like I say, hope you all have a great weekend. I'll see you on Monday.